how we extended the inspired data models in the GeoSmartCities project. The project has just ended on last February. GeoSmartCities aimed at leveraging the open geodata for the use within smart cities, or for the management of smart cities. So we will start with having a look at the methodology for the production of the extended data models, which was the approach we followed to extend, and we'll see some of the extensions and how we validate the extended schema we produced. So, which was the methodology for the production? One of the major challenges within the GeoSmartCities project was the interoperability of data, because we had data produced by 8 different member states. So we had 11 pilots, and data was produced by private companies, public authorities, even coming from crowdsourcing, so very heterogeneous data. And the Inspire directive was the basis, was underpinning the whole data modeling process, because it was a common base for all the member states. So we first collect the requirements. We create a template file to collect the user's data modeling requirements in a structured way. So they sent us, let's say, a list of information. In the most cases, they did not have a data model. They just sent us also document, Word document, whatever. Then we try to align different pilots' data modeling requirements. We try to group them into common classes. And we compared the requirement, the so-collected and grouped requirements, to the relevant inspired data specification. In this case, GeoSmartCities focused on 2 different scenarios, which are very important for smart cities: the green energy scenario and the energy performance of buildings. So we extended buildings to D. And the underground scenario, which dealt with the integrated management of utility networks. We used, of course, the mapping table to make the requirements collected and analyzed and grouped and so on with the data specification. And then we included in our extensions all the requirements that were not included in Inspire, coming from the different pilot use cases. We also provided instructions for maintenance of the schemas, so our procedures on how to ask changes, how to give us feedback and deliver new versions. And in the end, we validate results. So we validated the schema, the extended schema we produced against encoding requirements, and we will see. So, which was the Inspire extension approach? We decided to stick completely to the Annex F for the generic conceptual model, so do not change anything in the Inspire data specification, do not change anything in the model, in the application schema, and do not break any requirement. We decided to extend the core data models. So we imported core schemas in GeoSmartCities extended schemas. So our application schema is an import statement importing the core model. What about the Inspire extended schemas? we already have heard this yesterday, the presentation of the building of the energy pilot from JRC. Our first attempt, our first idea was to extend the Inspire extended schemas available in the draft repository of the JRC. But then we changed our mind because of some issues, so validation issues related to the extended schemas in the draft repository. For example, we have seen yesterday the issue related to the double inheritance of the building in the extended schemas. So, and for the underground, there were also another important issue that made us decide for just directly extend the code and do not import in our extended schema the Inspire extended. For example, in the sewage network application schema, we realized that the sewer network extended available in the draft repository of Inspire extends the sewer pipe feature type, but does not generalize the base extended. So if I need both base extended and sewer network extended, I cannot use the application schema available in the draft repository because I don't see the extended common base for the all utility networks. We will see in a slide, so it will be clearer. So we just imported core, we did not import extended, but we decided to reuse and customize when needed feature types, data types, and properties already defined in the extended schema. So to reuse the concept and the elements already defined there that we needed. So not to reinvent the wheel any time. This is the green energy scenario data model. This is, I'm trying to find the content. No, this is, oh, okay. So double inheritance was solved just transforming the feature type in a data type. So that the double inheritance for the building, you can see it here, because the feature type building info has been transformed in a data type in our extended model. So simply we will have in the building an attribute building info with all these properties available. We also, of course, provided new feature types, data types, and code lists, above all to include information about performance of the buildings. And we also reused concepts defined in CTGML IDE. The underground scenario data model. So, our extended schema extended the utility network profile, and how does it? We introduced a new common type application schema, which contains definitions for feature types and data types, which are not present in the SPI core, and that are common to all extended schemas. It will be clearer later, because we will see which are the classes in this application schema. And then we produce one common schema and a 6 network-specific extended application schema. We decided also to extend telecommunication network. Also, it is not mandatory in Aspire, it is optional to provide, but with broadband mapping, it is becoming more and more important. So we needed to extend this For example, to include information about the number of cable present in Belgian form, people to know how many cables are already there, if there is room, and what else. So, in particularly interesting was the focus on the Italian use case, because our pilot, the Italian pilot, wanted us to align to the Italian national specification on utility network. So we extended Inspire and included all the elements which are mandatory in our Italian national specification. And also there was an interesting pilot with the Flanders region, because in this case we included properties present in oh, what happens? What should I do? This one. Yes. La. Okay. We extended to include EQS2 data model, which in turn extends IMKL data model. Only 4 minutes. Yes, okay, let's go very quickly. So which were the patterns we used? As model compliance, we said we stick to generic conceptual model. And for adding classes and properties, we just used inheritance and association, so we just subtype it and included new associations, new data types. And we extended the code list and added constraints. So this is the new application schema. Yesterday we talked about excavation damages. We created a feature type, underground works, which takes into account this needs from the pilots, from the member states, and also crowdsourcing feature type, and also features related to management of the projects. This was asked by the Flemish pilot. This is the way that they handle the projects related to the utility networks. Then I'm just showing one extension, the sewer network. More or less, we followed that methodology. So more or less, this is the way we extended all the utility networks application schema. So what you see in green is the common utility network elements. So the core of the utility network profile, and also in red the sewer type is the core one. And then in blue there are the new feature types coming from the new application schema we defined for the common types, and in yellow, of course, you see the extended feature types. And you can see that we define new association for the extended feature types. So the feature type, the sewer pipe as a project association, for example, and as a dig, there is an underground work, for example, on that pipe, and so on. Code list register. Okay, we extended the code list. One of the code lists we extended with Amalia was the current use. Current use, so you don't need necessarily to stick to the values already provided, because it is extended, it's extensible with narrower values. So we also produced a video tutorial on this code list, on how to extend this code list with the GeoSmartCities, and it is available. So what did we do? We reused the registry software from the ARENA project. So we created our own register because Inspire requires that if you extend the code lists, you have to provide publicly, you have to publish the values in a common register. And so we make it available. The new values are available. The code list, you can see here the code list, and when you click on it, you find the new values and the old values, but of course in the description of the old values there is there's written that they are coming from Inspire code list, and there is the link to the original value. Just a note, now if you want to extend, there are the technical guidelines and best practices for the Inspire register and registries, which are available since last December. And GeoSmartCities is quoted already there because the extension of the code list is according to what decided officially. So I guess this is the last, oh no, it was not the last slide. Validation of extended schemas. We validated the schemas, the GML schemas, against GML encodings, against Inspire relevant schemas, and also against the requirements that are in the data specification, as we said yesterday, that cannot be validated by means of XSD, so by means of XML statement. And we used schematrons, and in some cases we did manually. And the validation tools that can be used, we used the EMB Plus validation service because it provides also a schematron, a GML schematron, so the schematron on GML application schema, and schematrons related to the specific themes. But you can also use Oxygen or XML Spy together with the schematron rules. And I guess this is the last one. Yes, thank you. Yes. No questions? Yes.
I will ask a provocative one. You have used